Good morning, all. I'm Sruthi P, Assistant Professor, Department of Electronics and Communication Engineering, Vedavyasa Institute of Technology. Today, I'm discussing about the topic FPGA. So, what's mean by FPGA? Field Programmable Gate Array. That means FPGA technology refers to field programmable gate arrays. That means a type of IC, integrated circuit, that can be programmed by customers after manufacturing to perform specific functions. So digital designers have various options, that means small scale integrated circuit, that is SSI, or medium scale integrated circuits, that is MSI. That means difficulties arise as design size increases, so interconnections grow with the complexity resulting in a prolonged testing phase. So we use PALs and PLAs. That means next step is simple programmable logic devices. That means PALs and PLAs. PALs means programmable array logic and PLAs means programmable logic array. So architecture, it's not scalable. Power consumption and delays play an important role in extending the architecture to complex designs. Implementations of larger designs leads to same difficulty as that of discrete components. So we have two choices. Then first one is MPGA and the second one is FPGA. So first one is masked programmable logic devices. That means it is customized during fabrication, low volume, expensive, prolonged time to market and high financial risk. So we introduced FPGA, field programmable logic devices, that is customized by end user, implements multi-level logic function, fast time to market and low risk. So two-dimensional array of customizable logic block placed in an interconnected array, like PLDs programmable at user's side. Like MPGAs implements thousands of gates of logic in a single device. So employs logic and interconnect structure capable of implementing multi-level logic. FPGAs after the benefits of both MPGAs and PLDs. So based on the principle of functional complexities, FPGA, that is functionally complete elements placed in an interconnect framework. So interconnection framework comprises of wire segments and switches provide a mean to interconnect logic blocks. So circuits are partitioned into logic block size, mapped and routed. So the next is technology of programmable elements. It's vary from vendor to vendor. All share the common property configurable in one of the two positions, on or off. It can be classified into three categories: SRM based, fuse based and EPROM based. So desired properties are minimum area consumption, low on resistance, low parasitic capacitance to the attached wire, reliability in volume production. So it can vary from vendor to vendor. Then it can be classified into three categories, that is SRAM based, fuse based or EEPROM based. Then its desired properties are minimum area consumption, low on resistance, high off resistance, reliability in volume production. So coming to the part of SRAM programming technology, SRAM means static RAM, that employs cells to control pass transistor or transmission gates. SRAM cells control the configuration of logic block as well. So volatile, that is needs an external storage, needs a power on configuration mechanism, in circuit reprogrammable, lesser configuration time, occupies relatively larger area. So coming to the next part, design steps involved in designing FPGAs. So it's understand and define design requirement. Next is design description. Third one is behavioral simulation, and next step is synthesize. And then functional or gate level simulation. Then implementing, that means fitting, place and route. And the next step is timing or post layout simulation. Last step is programming test. So there are commercially available devices. That architectures differs from vendor to vendor, characterized by structure and content of logic block, structure and content of routing resources. To examine, look at some of the available devices, that is FPGA, its ceilings, that is XC4000, then CPLD Ultra Max 5K. So First FPGA, Xilinx FPGAs. It's symmetrically array based. Array consists of CLBs, that is configurable logic blocks, with LUTs and D flip-flop. And also it consists of n input LUT can implement any input Boolean function. So Xilinx FPGA consists of n input LUT. It can implement any input Boolean functions. So array elements interleaved with routing resources. This is Xilinx FPGA. Then next is XC4000. It consists of 3 LUTs and 2 flip-flops in a two-stage arrangement. It have 2 output. It can be registered or combinational. External signals can also be registered. So it can implement any 2 independent functions of 4 variables or any single function of 5 variables. So these are the FPGAs, that is field programmable gate array. Thank you.